In the following video, we are going to solve a system of equations in 3 variables that has one solution. The key to solving a system of equations with 3 variables is to make sure your work is organized. Take your time, make sure you don't make small errors because the process is so long. If you make an error in the beginning, you won't know about it until the very end. And so we want to make sure though when we're doing this video that we take our time, we structure it, show each step, and explain it. And so we'll look at our 3 equations. 3x minus 2y plus 4z equals 35, and negative 4x plus y minus 5z equals negative 36, 5x minus 3y plus 3z equals 31. Now, in order to solve a system of equations in 3 variables, the key is you have 3 equations, 3 variables. You are going to do elimination 3 times. That's the key. 3 equations, 3 variables, we're going to do elimination 3 times. So let's keep that in mind when we're setting this up. And so first thing I want to do is I want to decide if I'm doing elimination 3 times, which variable do I want to eliminate first? X, Y, or Z. Now technically it doesn't matter, but you always want to choose the easier route. And so I'll look at X first. 3, negative 4, and 5. If I'm going to eliminate these, 3 and negative 4, I'm going to have to multiply both equations to eliminate the X. Negative 4 and 5, I'm going to have to multiply both equations. If I look at my Y, I have negative 2y, positive 1y, and negative 3y. Now, if I were to pair these up with the top equation and the middle equation, to eliminate the y, I'd only have to multiply the bottom one by 2. If I want to pair up the middle equation and bottom equation to eliminate y, I'd only have to multiply the top one by 3. And so there's very little multiplication. It's by small numbers. So that's how I'm going to pair them up. I'm going to choose to eliminate the y by pairing up the first and second and the second and third equations. So we'll call this step 1. Step 1, eliminate the y variable. And we're going to do it color coding. So we're going to follow our thought process. The top equation we're not changing. It stays the same. So I have 3x minus 2y plus 4z equals 35. Now the bottom equation of negative 4x plus y minus 5z equals negative 36 is going to change. We are going to multiply that by 2, and that's going to create my opposite of negative 2 and positive 2. So let's keep the top equation the same, 3x minus 2y. And notice when I'm writing this, I'm keeping them in columns separated and organized, so I have my variables like terms, like variables above each other. So now, negative 8x, when you multiply by 2, positive 2y, and then minus 10z equals negative 72. And since they are opposites, we just add vertically. And that's going to allow my negative 2y and my 2y to cancel. So 3x minus 8x, it gives me negative 5x. 4z minus 10z is negative 6z. And 35 minus 72 is negative 37. And so I eliminated the y variable in one of my pairing them up in one of the systems. So I'm going to eliminate for step 2 eliminate the y variable again. But this time we're going to do it in our second pairing. We're going to pair the second equation and the third equation together. And again, color coding this so I can see all the steps. So in that first equation of negative 4x plus y minus 5z equals negative 36, I'm going to multiply that, we said, by a positive 3. And the reason why is because that's going to help me eliminate the negative 3y in that bottom equation of 5x minus 3y plus 3z. Again, look at how I'm lining my variables up in columns, equals 31. And so let's distribute and write down what we get. So multiply all the terms by 3. That gives me negative 12x plus 3y minus 15z equals negative 108. And the bottom equations stay the same. 5x below the negative 12x, my minus 3y, you see they're opposites, my plus 3z equals 31. And I create opposites so I can add my two equations together. 3y, negative 3y, cancel. So negative 12x plus 5x is negative 7x. And negative 15z plus 3z is negative 12z. And negative 108 plus 31 is negative 77. And so now we can see the whole reason why I eliminate the y variable again is because if I take a look at my system that I just created, I have two equations. Negative 5x minus 6z equals negative 37, and negative 7x minus 12z equals negative 77. Two equations with two variables. I can actually pair these two together, create a new system, and eliminate one of those variables. So that's what I'm going to do. In step 3, you pair together the two equations. So we create a new system, and we eliminate one of the variables. And so I see negative 5x, negative 7x. I'm going to have to multiply 1 by negative 7, 1 by a positive 5. That's some work. Negative 6z and negative 12z, I see that 12 is a multiple of 6. So I'm going to eliminate my z variable here. So let's match up our systems. Let's create it. So I have my negative 5x minus 6z equals negative 37. And my other one is my negative 7x minus 12z equals negative 77. To eliminate the z, I have to create opposites. Since this is a negative 12, I want this to be a positive 12. So I'm going to multiply my top equation by negative 2. And that's going to give me my positive 10x plus 12z equals 74. And my bottom equation stays the same as negative 7x minus 12z equals negative 77. They're opposites of 12z and negative 12z, so I can add my two equations together, and that's going to cancel them out. So I have 10x minus 7x, that's going to give me 3x. 74 minus 77 equals negative 3. Divide both sides by 3, x is negative 1. And so by creating the new system, I choose which variable I'm going to eliminate, and I chose to eliminate my z because it was easy to do. But now I have x. Well, if I have x, what I can do is I can plug it in to one of these two equations and solve for z. And so step 4 is substitute in to find z. Now it doesn't matter which equation I use, if it's the negative 5x or if it's the negative 7x1. So I'm going to use my negative 5x1. So I have negative 5x minus 6z equals negative 37. I'm telling you x is negative 1. So that's what we're going to plug in. I have negative 5x, so I have negative 5 times negative 1. That's going to give me a positive 5. So I have 5 minus 6z equals negative 37. Subtract 5 from both sides, negative 6z equals negative 42. And then divide by negative 6. Z is a positive 7. Now think about what we just have now. We have the x, we have the z. This is a system of equations with 3 variables. We now know 2 out of the 3 variables. And so step 5 for us is to substitute in to find the third variable for us, which right now is y. So I'm going to grab one of the original equations. And the one I'm going to use, it doesn't matter. You have 3 to choose from. The one that I'm going to use is the middle one, where it says negative 4x plus y minus 5z equals negative 36. And I'm going to plug in everything I know. I know x is negative 1, so I have negative 4 times negative 1. I know z is 7, so I have minus 5 times 7. So here's what that gives me. Negative 4, negative 1 is a positive 4. So I have 4 plus y. Negative 5 and 7 is a negative 35. So I have minus 35 equals negative 36. You combine like terms. 4 minus 35 is negative 31. So y minus 31 equals negative 36. Add 31 to both sides, and you get negative 5. And so x is negative 1, y is negative 5, z is 7. We said in the introduction, your answer is an ordered triple. X, y, z. And that ordered triple is the solution for this system of equations. So I'm going to scroll up. I want you guys to see all of the steps. And sorry, this is my step 5. We have 3 equations, 3 variables. I said we do the elimination 3 times. So we did elimination once, did elimination twice, use those 2 new equations to create a system to eliminate the 3rd time. After we do that, we substitute in step by step to get all of the variables. The key for this type of process is to organize your work. And you can see it's a lot of thought that goes into the problem. And there's a lot of chances to make small mistakes. And that's where the problems occur. So make sure you take your time when you distribute to all the terms. Don't forget one. Make sure you organize the work. Maybe follow the same structure that we did here to make it easier to see each step. And then go through elimination 3 times and then substitute your values in. Watch more videos for some more examples.